This is Math with Mr. Sneed, and this is solving linear systems by linear combination or elimination. This is example 2, continuation of the previous video. Example 2 says, solve the linear system using the linear combination or elimination method. So this time, again, we're still looking for the same idea as before. We're looking for one of the variables that when I add it together, they cancel out. So if I look at my x's, 5 plus 3 is 8, and that won't cancel. If I look at my y's, I get -4 plus 2, which also doesn't cancel. So this time I have to do an extra step. Okay, this time I have to multiply. So looking at my variables, I want again them to be opposite signs, but the same coefficient. Okay, so looking at the y's, I already have opposite signs, and I know I can multiply 2 by something to get 4. So I'm going to target my y and try to get rid of y, which means that I need to multiply the second equation by 2. Okay, I'm going to multiply the second equation by 2. Let's do this. We'll stick it out in front. So my first equation doesn't change. It's still 5x minus 4y equals -22. My second equation, 2 times 3x is 6x. 2 times 2y is 4y. And 2 times 44 is 88. Okay, so that was our step 1. We had to multiply. Our step 2, we're going to add these two equations together. And when we add, we get 11x. The y's cancel. And we have 88 minus 20, or plus -22, which is 66. Okay, so again, first step was to multiply so that we have the same coefficients but opposite signs. Okay, or the same numbers in front of y but the opposite signs. And the second step was to add the two together. Now we need to finish the second step by solving for x. So I'm going to divide both sides by 11. Since 11 is being multiplied to the x, we get x equals 6. So now I'm going to take and plug that back into one of the two original problems. So this is step 3. So smaller numbers, it looks like the second one for the most part. So we get 3 times 6 plus 2y equals 44. 3 times 6 is 18 plus 2y equals 44. I need to get the 18 to the other side, so I'm going to subtract 18. So we get 2y, the 18's canceled. 44 minus 18 is going to be 26. Then we're going to divide both sides by 2 and get y equals 13. And the last step, step 4, is then to write our answer as an ordered pair, 6, 13. So what I'd like you to do now, I'm going to pause it. I want you to you try it, and then I'll unpause it and you can check to see how you did. And again, I'll give you a tip. we want to eliminate y because again the signs are opposite and it's easy to multiply this to be the same. So I'm going to go ahead and pause it now, and you're going to go ahead and try it. Okay, so now that you've tried it, trying to eliminate y, I have to multiply the second equation by 7. So the first equation is not going to change. It's 3x plus 7y equals 85. The second equation is going to be 7 times 4 is 28x. 7 times negative y is negative 7y. And 7 times 72 is 504. So there is my step 1. Step 2, we're going to add these together. Again, if we did it right, a variable will be gone. So the y's cancel, and we get 31x equals 589. We're going to divide by 31. So then we get x equals 19. Then we go to step 3. We're going to take that 19 and plug it in. I would say plug it into the, let's just go with the top one. 3 times 19 plus 7y equals 85. So remember that it doesn't really matter which equation you plug it into. I just tend to try to make the numbers smaller when I work. Okay, so 3 times 19 is 57. Then we have to subtract 57 from both sides. So we get 7y equals 28. We're then going to divide by 7. And we get y equals 4. In the last step, we have to write it as an ordered pair. 19 times 4. And so this example is an example where we had to multiply one of the equations by a number so that we can add them and cancel. And with that, your second example is done.